Hello everybody, so today I will talk about calculus. The topic today is about application of derivatives. So now I will show you how to answer. We want to find about critical points and inflection points. To do about this one, we need to find first derivative of the function. This is for critical points. And second derivative of the function. This is for inflection point. So let's go to the first one. We can apply about the quotient rule of derivative. That means we have y equals to a over b. So if we do first derivative of this one, we need to do first derivative of a multiplied by b minus we do first derivative of b multiplied by a, and we have b squared in here. Now we can apply the formula in here. So we need to do first derivative of s squared multiplied by s squared plus 7 minus we do first derivative of s squared plus 7 multiplied by s squared in here. Later that we do first derivative of s squared plus 7 to the power of 2. Next we have the formula in here. If we do first derivative of this one, we have ns to the power of n minus 1. So we have s squared in here. So n equals to number 2. So if we do first derivative of this one, we have number 2 s to the power of 2 minus 1. That's about number 1. So for this one, we have 2s. This one, we do first derivative of s squared, you got about 2s. Number 7, this is about the constant. First derivative of the constant, you got about 0 in here. Next, we have 2s. 2s, we can do about factorization. So s squared minus s squared, you got about number 7. 7 multiplied by number 2, we have 14. After we find first derivative of the function, we can put this one equals to number 0. That means this one equals to number 0. So we simplify and we have 14s equals to number 0. And we have s equals to number 0. After we find number 0 in here, we put number 0 go back to this one. So we put 0 in here, 0 in here, and you got about 0. And we have critical points. That's about 0, 0. Now, let's go to find second derivative of the function to find about inflection points. So we use this one in here. So we apply the same formula about the quotient rule of derivative. So we will have about first derivative of 14s multiplied by s squared plus 7 to the power of 2 minus we do first derivative of this one multiplied by 14s over, so we put this one to the power of 2 again, so you got about number 4 in here. So this one we have 14. This one we can apply about the chain rule of the derivative. That means if we have y equals to a to the power of n, if we do first the derivative of this one, we have n a to the power of n minus 1, and later that we do first the derivative of a. So this one we will have about 2 multiplied by s squared plus 7. Later that we do first the derivative of s squared plus 7. So this one we have 2s. Now we need to simplify s squared plus 7 on numerator and denominator, because we have this one and this one. So this one we will have about s squared plus 7. This one we simplify. So we have number 2, and 14. This one we have 56s squared. And this one we simplify, and you got about number 3 in here. Now we need to expand this one. So 14 minus 56, we have negative 42. And later that, we put second derivative of the function equals to number 0. That means this one equals to number 0. So we just have only numerator can create number 0 in here. So I will put 42s squared go to the right. Later that we divide both sides by 42. So we have about 7/3. Next, we put the square root for the both sides. So we have s equals to the square root of number 21/3, and s equals to negative with the square root of number 21/3. Later that, we put this one, go back to this equation to find the value of y. So we have y equals to 1/4, and this one similar. So we have inflection points. And this is the final answer. This is the end. Thank you for watching.